Alright, so question reads, a 2-carat diamond contains approximately 0.0315 moles of carbon. They tell you what it is, right? Moles of carbon. And then asking how many particles of carbon are found in this diamond. Okay, if you look at your notes, we say for every 1 mole of anything, in this case, what are we going to talk about? Carbon, right? So you have 1 mole of carbon. For 1 mole of carbon, how many particles do I have? Good, 6.02 times 10 to the 23 particles. Now, this relationship, moles to a particle, it would still be the same if I decided to ask you about gold, aluminum, chlorine, right? Because as long as you have 1 mole of anything, you're always going to have 6.02 times 10 to the 23 particles. Now, remember back 2 slides back, I asked you, what if you had 2 moles? What do we say we're going to do with this? Multiply by 2, right? So we're kind of doing the same thing, but instead of 2 moles, I had 0.031 moles. So an easy way to set this up is that we're always going to start with what's given to me. I am given 0.0315 moles of carbon, right? Set up the ratio. You have to cancel this out to get the particle unit. Remember, this top part is a conversion factor. If we put this in a more manageable form, like a fraction, what is it going to have on the top? We want 6.02 times 10 to the 23 particles at the top, because if I have particles at the top, what has to be the unit at the bottom? Moles. But how many moles are there for 6.02 times 10 to the 23? 1. So what cancels out? Moles of carbon cancel out. And now let's take out the numbers. Remember, this has an invisible 1 at the bottom. Multiply across just the top one, multiply the bottom numbers, and you just divide, right? So when you do the math, you end up doing 0.0315 times 6.02 times 10 to the 23. What's the unit? That's the only thing that's left over. Particles of what? Carbon. And when you do the math, that's what you should get. Okay, this is an important diagram because this tells you that if I have a mole and I want to go to atoms, molecules, and formula units, I have to use this number. Vice versa, if I have atoms, molecules, or formula units, and I want to get to moles, I use the same number, right? And mole always gets a 1. So if there's 1 mole, I have 6.02 times 10 to the 23 atoms, molecules, and formula units. If I have 6.02 times 10 to the 23 molecules, atoms, formula units, I have 1 mole. Okay, so they give you the problem that said each day the average person in the US generates 7.81 times 10 to the 25 molecules of carbon dioxide. How many what? How many moles? So we're still going from representative units, which is molecules, to moles, right? Okay, how many moles of carbon dioxide are emitted by the average person in 1 day? Well, let's find out. So we're going to start with 7.81 times 10 to 25 molecules. Okay, I'm going to step aside a little bit. Okay. It's over an invisible 1, so it makes it easier for us to calculate. And then for every molecules, you have a mole. Can someone tell me why with the molecules at the bottom? Because we need to cancel out the unit molecules, right? I have to have the same unit across from to the bottom of it. So now let's fill in the number. What are the numbers? Good. 6.02 times 10 to the 23 molecules for every 1 mole. Because, why wouldn't I put it on the top? Because look at the roadmap that you just draw. Mole always gets what number? 1. The mole always gets 1. Because we need to cancel out the molecules. If you don't have the molecules at the bottom, and if it's at the top, these units will not cancel out. You cannot cross multiply. So, you end up cross multiplying. Molecules cancel out. Now, does the numbers cancel out? The numbers do not cancel out. So when you do it, you get 129.734 moles, which with 3 sig figs have 130 moles of carbon dioxide. That is not my baby. Just for clarification, this is not my baby. If you have numbers next to each other, like here, you have 7.81 times 10 to 25. That's next to 1. Multiply or divide? You multiply these. 7.81 in this case times 10 to 25 is at the top in relationship to 6.02 times 10 to 23. Multiply or divide? Divide. Basic math, guys. You did this in algebra. Okay, so you end up multiplying 7.81 times 10 to 25 times 1. Divide that by 1 times 6.02 times 10 to 23. And that gives you 129.734 moles. So what are we starting with? Times 10 to the what? Okay. Alright, here's the thing. So we are now getting the idea that this is the number that we start with, right? And some of you guys asked me, what is a unit? Well, it tells you that it's 5.15 times 10 to 21st, 4 million units altogether, right? Okay, what are we trying to convert to? Moles. So let's go ahead and start with this. Okay, so you end up with, you start with 5.15 times 10 to 21 formula units. For every how many moles do I have this many formula units? I have 1 mole for every one of these guys. It doesn't matter what the identity is. Cancel out the formula units. Let's do it with the red. And you end up doing 5.15 times 10 to 21 divided by 6.02 times 10 to 23. Pencil lead or graphite is made up of the atom carbon. If there are, what's given to me? 3.4 times 10 to the negative 2 moles of carbon in 1 piece of lead. What is the mass of a piece of lead? Okay, this is a time where you take out your periodic table. So go ahead and take your periodic table out and someone tell me the mass of lead. That on the periodic table, there is this symbol Pb, and underneath it says 207 point what? 2. This 207.2, mark eyes up here, 207.2 is the mass of lead for every 1 mole. Per 1 mole. So now, I got another conversion factor. So let's go ahead and set it up. I'm going to erase this so I can make some room for my equation. I have 3.4 times 10 to the negative 2 moles, and that's what you guys said I need to start with, right? And I found the mass of lead for 1 mole from what? The periodic table. This tells me that there are for every 1 mole, I have typo. What is it supposed to be? Oh, wait. Carbon, not lead. I'm sorry. That was my fault. Pencil lead or graphite is made up of carbon atoms, not lead. In my head, I said lead, but it's carbon atoms, right? So, carbon has a mass of 12 grams. Good. So now, what cancels out? The moles cancel out. What is my unit that's left over? Grams. Now, Amaya, remember this number has 1 at the bottom, right? So am I going to multiply these numbers or divide numbers? They're next to each other. Multiply. So when you multiply, you get 0.40834. Let's round it up to 2 sig big, 0.41 grams. So, yeah. No. We're going from moles to mass. Mole always still gets 1. But this time the number of the mass is going to change. And we get this number from the periodic table. And we did that thing on Monday, right? Where you add different atoms mass. That's where that comes in handy. So that comes from the periodic table. Alright, so one of the most common gold compound is gold 3 chloride. How many moles are found in 50 grams of gold chloride? This problem is actually more complicated, it seems, because you need to first write down the formula of gold chloride. So let's go ahead and write down the gold chloride formula. Gold is positive 3. Chloride is negative 1. Crisscross, so I get AuCl3. That's the mass that I need to find of 3 chloride and 1 gold. When I do that, I get this, 303.32. When I do the math, I get 0.16484 moles of gold 3 chloride. All right, I'll fill it back up tomorrow here.